How's it going, class? This is Benji, and today we're going to talk about molecular polarity. Now, molecular polarity is defined as a physical property that refers to a permanent partial charge separation within a molecule. As you can see, we have the partial positive sign and partial negative sign denoted here. Now, what is a polar molecule? Well, for the most part, there's a direct correlation between the polarity of a molecule and the number of polar or nonpolar covalent bonds present in the molecule. However, in a few cases, a molecule may have polar bonds, but the symmetrical arrangement of the bonds within the molecule makes the molecule as a whole nonpolar. And this will become clearer later in the presentation. Now, Dave told you a little bit about polar bonds, in that polar bonds have to do with the electronegativity difference between the two elements present in the bond. And so we're going to move on to some examples. Let's first look at water molecules. Water molecules are polar because the oxygen-hydrogen bond is a polar bond, and the shape of the molecule is not symmetrical, it's bent, meaning that the molecule as a whole is polar. Now, carbon dioxide, on the other hand, is a nonpolar molecule, even though the carbon-oxygen bond is quite polar, but the symmetrical structure of carbon dioxide molecules makes the molecule as a whole nonpolar, because those bonds are on like a straight line, so the polarity of the bonds cancel each other out in the molecule. So molecular polarity relates to a few other topics in chemistry, including melting points, boiling points, and solubility. This is because molecular polarity has to do with how tightly the bonds are packed within this molecule and how tightly the molecule is pulling those bonds together. So it's going to have a higher melting point or a higher boiling point, or a higher melting point. Those points will be higher or lower depending on how polar the molecule is. Now let's work a sample problem. Here's the molecular structure of ammonia, NH3. The nitrogen is denoted by that big blue ball, and the hydrogens are denoted by those small white balls. So, are ammonia molecules polar and nonpolar? Well, let's break it down. We're going to see that the bonds present in this molecule are nitrogen-hydrogen bonds. And this bond is indeed polar. Now we're going to look at the structure. You see that the structure is actually non-symmetrical because there's a lone pair at the top of that ammonia, at the top of that nitrogen in that ammonia molecule, which pushes all those bonds down, which makes the structure non-symmetrical, which makes the molecule as a whole polar. Now it's time for you to try. Here's carbon tetrachloride. I'm going to tell you a few things for you to do the problem. First is that that black ball in the middle represents a carbon, and those green balls represent chloride or chlorine. So now, and also I should tell you that the carbon chloride bond is indeed polar. So I'm going to wait for a few seconds, and you're going to do this problem. Pause the recording, and we'll get back. Alright, we're back. So, carbon tetrachloride molecules are actually nonpolar. And if you guessed that, you are correct. The reason is because even though the bond of carbon and chlorine is indeed polar, but the symmetrical structure of the molecule makes the molecule as a whole nonpolar. So, yep, that's it. The end.
That was easy.
And I'll see you in class.